Welcome to another conceptual video for class 12 students. This is a question from the chapter Applications of Integration. Draw the rough sketch of the curve y is equal to 10 cos 2x. If you observe, this is a cos function and it has 2x angle where x is given in a particular interval. Using integration, find the area of the region bounded by the given function from the ordinates, so on and so on. Okay. So we are going to convert this 2x to theta. So the angles are also going to change. If 2x is equal to theta, that is x is equal to pi by 6 to pi by 3. So 2x is going to be from 2 pi by 6, which is pi by 3. So that would be 60 degrees to pi by 3, so that's 2 pi by 3, which is 120 degrees. So theta belongs to the interval pi by 3 comma 2 pi by 3, and it is 10 cos theta. So the y function now becomes 10 cos theta. Cos theta has a range of -1 to +1. So 10 cos theta would range from -10 to +10. Using integration, find the area of the region bounded by, okay. So we have to find the area of the region y is equal to 10 cos theta from x pi by 3 to 2 pi by 3. Here, this is 0 and let's say this is pi by 2. Pi by 3 would be 60 degrees, which is somewhere here. And 2 pi by 3 would be somewhere here. So we know how the cos function looks like in terms of graph. So here is pi by 2. It becomes 0 at pi by 2. And it goes on and on until here. That is pi, which is -1. But we want only this region. So from here to here. And it is also said that we have to amplify the cos function by 10 times. So here, this would be 10. So when theta is pi by 3, that is x is equal to pi by 6. And when x is equal to pi by 3, y would be equal to 10 times. So when theta is equal to pi by 3, what is the value of cos? So cos theta would be equal to, which is cos 60, which is 1 by 2. So y would be equal to plus 5 actually. So 10 cos theta, which is 10 cos of 10 into 1 by 2. So that would be 5. So when theta is 2 pi by 3, which is in the second quadrant, so cos has to be negative. It will be negative half. Y is equal to 10 times of minus half, so that would be -5. So here the value would be 5. It is not 10, it is actually 5. The maximum value would be 10. Here it would be -5. So we require only this part. So we have to mark it here. So from here to here, we only want this part. So you can show the interval marking. So here x belongs to pi by 6 comma pi by 3 with closed interval back brackets. Y belongs to -5 comma +5. So this is the range of y. But for this question, for this range, for this particular interval of x, the range here is -5 to +5. And the graphing here is only from this part to this part. And this would be the graph of the given y function. For this question, we also have to find the area of the region enclosed with respect to the x-axis. It is given the same function between the ordinates x is equal to pi by 6 to pi by 3 and the x-axis. If you observe, this is from 60 degrees to 120 degrees, and the region rests completely on x-axis, which means you will have to take the area and make it 2 times of integration of, you either choose this one or this one. I'm choosing the one that is upright above the x-axis. So these two are symmetrical because the regions are they are 30 degrees apart from the midpoint, which is 90 degrees. So 2 times of pi by 3, I'm going to use the theta function. So y is equal to 10 cos theta, 10 cos theta d theta, and the above value, this would be between pi by 3 and 2 pi by 3, we have pi by 6. Or wait, so that would be 1.5, which is pi by 2. I'm sorry, this should be pi by 2, correct. So 2 times, make it 2 into 10, which is 20. Cos theta would be, if you integrate cos theta, that would be sin theta. So you will get pi by 3, pi by 2. So that is equal to 20 times of sin pi by 2 is 1. Sin pi by 3 is root 3 by 2. So if you multiply 20 inside, you will get 20 minus 10 root 3 approximately. That would be 20 minus 17.3. So that would be 2.7 units. That is the required area.